All right, so we are streaming and audio seems to be good. So is that audio problem, the clicking, recurring, or does anyone know, with all the later recordings, is that still a problem? Nobody knows? Yes? No, not a problem. Okay, okay, thank you. All right, so last time we started to talk about records, and we used an example that's kind of a little bit long. Okay, we were comparing dates. So on that topic, okay, let me see if you guys, can think of a better way to represent time and date. So the normal way that we represent time is pretty easy. We got hour, minute, and second, right? So even if you were to use 24-hour format, you will still be representing the current time as 1300 hour, 33 minute, and whatever the second is. So when you look at how we compare time, it's still kind of the same thing as comparing a date. In other words, you look at the hour first. If one time has an hour that is before the hour of the second time, then we know the first time is before the second time. If they are the same, then you have to look at the minute. If both the hour and the minutes are the same, then you have to look at the second. So you're still looking at a pretty complex logic just to compare two times. Is that okay? So when you have time and date together, then you have 6 different things to compare. Starting with year, then you have month, then you have day, then you have hour, then you have minute, and potentially also second. So this way of representing date and time is friendly to human beings because we are familiar and used to it. But it is not so good when it comes to having a computer to work on it. Is that making any sense? Because in order to compare two times, I would just want to compare two integers. That's easily done. Okay, so internal to computers, they do not represent time and date as we do. They represent time in a very strange format. It is in terms of in numbers of seconds since 1970, January 1st for Unix type systems, and then for Windows, it's the number of seconds since 1980, January 1st. So it's only off by 10 years. It's off by 10 years because Microsoft did not write their operating system until 1980. And Unix was already around by 1970, so they used 1970 as the start time. Are we doing okay so far with that concept? Okay, so we're just counting the number of seconds. So now the question is, how do you convert between those two? If I give you year, month, day, and then hour, minute, and second, how do you convert that into the number of seconds since 1970? And if I give you the number of seconds since 1970, how do you convert that into a human readable date in terms of year, month, day, and so on? So that becomes a question. Okay, so what we'll do today is to continue the discussion of records because we are still representing time and date. Okay, but we'll also use this as an example in order to figure out an algorithm to do the conversion. So that's going to be what we'll be doing today. We'll be writing some code, and at the same time, we'll also be exercising what we have known already at this point about records. So are we okay with that kind of plan? Yes? Okay. All right. So what we'll do is we're going to start with pseudocode. The pseudocode is going to start with the definition of two record types. So we have a date record. This is the same as before. So we have year being an integer, month being an integer, and then day of month is also an integer. This is how we look at a date. This is a human readable date. And just like this, we have a time. Okay, the record itself should not be uppercase, so R should be lowercase. So we also have a record for time, which, as I said a little bit earlier, has hour, minute, and second. So I'm defining basically two cookie cutters. Okay, they do not, nothing starts to exist yet. Okay, this is really just a template of if we have a time object or a time variable, it's going to have the three members, hour, minute, second. So we are only setting up the template. Are we okay so far at this point? Okay. So now we'll try to write a subroutine. Define sub. Which one do you guys want to start with first? Do you want the one converting from number of seconds since 1970 to date and time, or do you want to convert the other way around? The other way around is easier, so why don't we start with that? So given date and time, okay, how do we convert that particular representation into the number of seconds since 1970? Is that okay? All right. So we'll go ahead and write that. And that particular type of time format or time representation is also known as epoch. So if you look at epoch time definition, it's also known as Unix time, and this gives you a full definition of what it is. But you can actually read it from right here, just the summary. It is 000 in UTC. What is UTC? Universal Time Convention. It is a French word, so the ordering of the words is a little bit different. It is also what we know before UTC. This is what we know as GMT. What is GMT? Greenwich Mean Time. Okay, they mean exactly the same thing, just a different term. I guess people are not they're sick and tired of using Greenwich Mean Time, because I think Greenwich is a place in England, and everybody else is complaining. How come you get a name of one of your cities into an international standard? So then they turn it into UTC, Universal Time Convention. Okay. So going back here, so we'll say just epoch, okay, or we can say Unix time. Okay, Unix time works good. What parameters do you think it needs? In other words, the caller or whoever is invoking the subroutine needs to supply something. What do you think the caller needs to supply? What are we converting from? Go ahead. Sorry? The year, month, huh? Yeah. Yes, okay, so we need a date and a time. Okay, so we need those to begin with. So before we have records, this is very tedious, because now we have to say by val year as an integer. So don't write this down, because I'm going to change this really fast. Then we have month, which is also an integer. We will have 6 of these parameters, right? Because 3 for the date and 3 for the time. That's not how we do things anymore. Okay, so now we have D as a date, and then we have T as a time. Now, whether you want to pass these by value or by reference, there's a little bit of discussion here. If you pass by value, that means whatever you use to specify the parameter cannot be changed in the subroutine, because that's the whole idea. By val means we are having a copy of what you use to specify for this particular parameter. It is not a reference to the original thing. So that means we can mess around with D and T all we want inside the subroutine, and nothing is going to happen to the original item. That's the advantage of passing by value. So what about passing by reference then? So if I change this to pass by reference, what is the impact? Well, the impact is, instead of passing 3 different things for date, you're using 3 columns, and then using also 3 columns to pass to T, we're only using 1 column for each parameter, because that column is only going to tell us where to find a date object and where to find a time object. So it is much more efficient in terms of how you use the memory of a computer system, and it is also more efficient because you don't have to copy things around a lot. Okay, so it's nice in that way. But now we're exposing whatever you use to pass to D and whatever you use to pass to T, because they're passed by reference, which means if I accidentally change any one of these 2 records inside Unix time, that change is being done to the original item. So it is an exposure, but it is also more efficient. So in C and C++, okay, I'm not going to use this too much in this class, but in C and C++, you can declare the parameter as const, which means even though it is passed by reference, don't change it. It is just a rule that a compiler is going to enforce. So any assignment operations that has d dot something on the left-hand side, the compiler will frown at that and go like, hey, you're not supposed to change whatever d is referring to. So it's something that is enforced by a compiler, which we don't have in this class. And because we don't have a compiler, we're not going to introduce this concept. But in your next class, when you pass something by reference, you can declare that something is passed by reference, but it is also const, which means even though technically you have the means to change whatever it is, you're not allowed to. Yep.
So what's the point of passing the references?
Being more efficient. So it is still more efficient. And then the other reason why, when you have record types, you see a lot of record types being passed by reference, is you can't specify a record like you can with an integer. With an integer, you can go like, okay, I'm passing 4 times x as an expression by value to a parameter. But you cannot create a record or on the fly. It cannot just pop out of existence. So it doesn't matter. So passing by value doesn't work as well with record types as it does with integers or numbers. So we're going to pass these two by reference, just because it is more efficient. So now the question is, okay, now we got the date and we got the time. How do we do the conversion? So let's take care of the number of days first. So as a local variables, I want to count days first. In other words, from 1970, January 1st, to the date that is stored in my parameter d, or whatever it refers to, how many days are within that time frame? That's what we want to compute first. So how would you go about doing this? It has something to do with 365. Yep, okay, that's good. Except there are leap years and non-leap years. So before we can do this part, maybe we can consider another subroutine to define whether a year is leap or not. Okay, so we'll define this other subroutine, which only has one parameter that is passed by value. So in this case, it is y, which is a year, and it is of a type integer that is passed by value. So in this case, can we pass this one by reference to? Yes. But are we going to gain anything passing the year by reference? The answer is no. Because whether you pass it by value or by reference, y is going to take up one column anyway. So you're not going to save anything, in terms of, how many columns you're going to use or how much time you use to copy things around. It doesn't save you anything. In fact, if you pass it by reference, now it is slower because every time you look up y, you have to say, oh, y is not a value. What is it referring to? So every single time you use y as a parameter, you have one extra step to find out what column it is referring to. So in this case, passing by value is the correct thing to do. It makes sense. Okay? Okay. So now how do we decide whether a year is leap or not? So unless you want to look up Wikipedia, how many people remember the first rule, the easiest rule about whether a year is leap or not? Every 4 years. Okay, so if a year is divisible by 4, there's a good chance that it is a leap year. Okay, that's good. So how do we check whether a year is divisible by 4 or not? Which operator may come in handy? Yep. Mod, very good. The remainder, okay? So now we want to say if y mod 4 does not equal to 0, then we go for one branch. Otherwise, we go for another branch. Okay. So when it does not equal to 0, what can we return something for sure? In other words, if I'm looking at a year where if you divide the year by 4, it will give you a non-zero remainder. What does that mean? Is that year leap? It cannot be leap, okay? Very good. So we can return false, okay? So in this case, we can return false, meaning that whatever parameter you pass as y is not a leap year. Are we good so far? Okay. Now, you might want to say, maybe we just do it this way. Well, that is not actually going to work. It will work most of the time, but not all of the time. So what if, besides divisible by 4, what other rules do we have that determines whether a year is leap or not? Nobody knows. What about 2000? Year 2000, was that a leap year? It was not a leap year. Even though it was divisible by 4, but it was also divisible by another factor that made it not a leap year. Okay? So, how do we know? How do we decide whether a year is leap or not? What? Hmm? Okay, let me roll back one more step. Okay, so I'll roll back one more step. What determines the number of days in a year? What is the natural phenomena that actually determines the number of days in a year? The sun and the earth, okay, both. What is a day? A day is self-rotation of the earth, right? It's how long it takes for Earth as a planet to go around one revolution. That amount of time is a day. What about a year? What is the natural definition of what a year is? The amount of time for Earth to go around the sun one time, right? So what makes you think those numbers must be 365 or 365, some numbers like nice like that? It is not. It is an irrational number. Does everybody know what is an irrational number as opposed to a rational number? No? Yes? What is a rational number?
Indivisible.
It can be expressed as a fraction, where the denominator and the numerator are both integers. Okay, it's a very loose way to define it, but it's close enough. Okay, so pi is not a rational number. Pi is an irrational number. Why?
Because it's continuous.
And but it's not. It's also not recurring. Okay, like 1 divided by 3 keeps on going, but you're recurring just the 3. So pi does not have any recurring pattern. Okay, it cannot be expressed as an integer divided by another integer. It's irrational. So as it turns out, of days in a year is also irrational. It keeps going and going and going. Then what about that 365 days and a quarter? It's an approximation. It's just an approximation. Okay, so now if I need to determine whether a year is leap or not, what do I need to do? Well, we can look up number of days in a year. And, oh, that's useless.
Calendar year. That's a calendar year. Let's change it to something else.
Nah, calendar year, day is, okay, it says a day is this much of a calendar year, I think. Hmm? It is so slow. Is it still alive? Yep, still alive. Okay, maybe we'll look up something else. Leap year rule. Okay. There we go. Every time I click on Wikipedia, it takes a long time. Actually, year 2000 was a leap year. I just remember because there's every 400 it is not a leap year, and then every 1000 or 2000 is a leap year again.
You can try open that one
Hmm?
under the portrait.
Okay, there we go. This is enough. This is enough for what we need to do. Okay. So every 4 years is leap, and then every 100 is not leap, and then every 400 is leap again. So when you look at year 2000, it is divisible by 4, which means, yeah, it's a leap year. But it's also divisible by 100. Oh, it's not a leap year. But then it's also divisible by 400. Yeah, it's the leap year again. So year 2000 was actually a leap year. 2100, year 2100 is not a leap year because it is only it's divisible by 4, but it's also divisible by 100, but it is not divisible by 400. Okay? Now, do you think these are the only rules to decide whether a year is leap or not? No. It keeps going, okay? But for our purposes, this is good enough. Because the next number up is going to be maybe a 2000 or 4000 ish. So this is all we need to do. Okay. So given this is the logic, how do we code this logic? I'm going to display the rule and also the code side by side. So when we get to this else branch in our source code here, that means y mod 4 is in fact 0. So now we need to decide, okay, but is it divisible by 100? So we need to say y mod 100, okay, is it 0 or not? If so, do one thing. If not, do the other thing. If it is not divisible by 100, then we are good. We can now return true because it is only divisible by 4 but not divisible by 100, so we're good. What if it is divisible by, the other way around. Sorry about that. So this is true, fine, no problem. But in this case, now we have to ask one more question. Because now we have to say, well, it is divisible by 100, but is it also divisible by 400? So now we have to check whether it's also divisible by 400. If it is not divisible by 400, then we return true. On the other hand, if it is divisible by 400, then we return false. And if here, so for some reason, I cannot get to a Wikipedia page, but the recording is still on, so I know I still have internet connection. So something odd is happening as far as what site I can get to and what site I cannot get to. But that's okay. Okay, we got all the rules that we need here. So we're doing okay so far with this code here, which is only to determine whether a year is leap or not. Yes? Okay, we good? Okay. All right. So we'll plug in a year just to check whether it works out or not. So let's plug in 2020 next year. Okay. So if y is 2020, we will first check is 2020 mod 4, which is 0. Is it different from 0? Nope, it is false. So if it is false, we get here, which then we ask is 2020 mod 100. Is that 0 or not? It is not 0 because it's 20, right? 2020 divided by 100 has a remainder of 20. So this becomes true, so we just return true right away, which means 2020 is in fact a leap year. That's correct, okay? We can plug in maybe this year, 2019. So 2019 mod 4 is not 0, so we just return false, which is also correct, okay? Because 2019 is not a leap year. So we just kind of do a little bit of sanity check, so everything seems to work out. Okay, so once we have that worked out, then we can go here and go like, okay, what do we do now? So what we can do is we can count year by year and just add either 365 or 366 to the total number of days since 1970. Are we doing okay so far with this? Yes? No? Maybe? Are we good? Okay. All right, so we have another local variable I, okay, which is just really something that we can use to control loops. And what we'll do here is the first thing we do is we initialize the number of days to 0 first. And then what we do is we initialize I to the start year, which is 1970. And then we say, as long as I is less than the year inside our parameter D, we'll do the following. So for each year that is between 1970 and the year prior to the date that I'm dealing with, what I'll do is I'm going to say I gets I plus 1. Okay, we're just, because I is just a counter, counting up to the current year, or the year prior to the current year. But I'm also going to increase the number of days. But how I increase the number of days has to do with whether the year I is leap or not. So I can't just do the update. I need a conditional statement. So the conditional statement, okay, I need to do this second. So the conditional statement that I need to use is to say is invoke is leap, is leap, and then I use I, which is a local variable of Unix time. I use that to specify y, which is a parameter of is leap. If that is returning true, then we increase the number of days by 366 because that's a leap year. If the subroutine returns false, then I increase the number of days by 365 because it is not a leap year. Okay, so let's just look at this loop here between line 37 and line 44 and ask, okay, does it make sense? Does it get out? Are the variables initialized correctly before the loop? So we look at I. I is initialized to 1970. Okay, that seems right. Do we want less than or equal to? Less than? Nope, we want less than. Now, okay, so here's the question. How do we do a quick sanity check to see whether less than makes sense or whether less than or equal to makes sense? That's the question, okay? So in a very extreme case, I can pass the date itself as 1970 January 1st, right? But in that case, I really do not have a year between the date that is given to me and 1970. So I should not be adding 365 in that case. So I only want to count up to the year prior to what D is representing. So do you see what I just did? I go for the extreme condition, like what kind of date range are we dealing with? What is the earliest date we can specify that makes sense in D? So I use that to check whether the logic works or not. Okay. All right. So if I is representing a leap year, we add the number of days by 366 because it is a leap year. Otherwise, we add 365 to the number of days. That seems okay. At the end of each iteration, I increment the I by 1, so it would go to the next year. And then once it reaches the year that I'm actually in, it would get out. So that seems to be correct, to me. Then what do we do? Now we have to deal with months. So months is a little bit more tricky to deal with, okay? So you can use the knuckle trick. In other words, you can try to code the knuckle trick, or you can have an initialized array so that you can rely on the array to tell you how many days are typically in a month. Are we doing okay so far with that? Is that okay? Okay, how many people have no idea what I'm talking about? Okay, so I'm guessing 2/3 of the class is too shy to raise their hand. That's okay, I will fix this. Okay, so one way to determine how many days is in a month, okay, so we're going to set it up the same way, where I is the beginning of all the months, So we will start with 1, which is representing January. And then we'll say, as long as I is less than the month that is represented in D as our parameter, we'll do this loop here. And in the loop, at the end of the loop, I'm going to add 1 to I, okay, because we want to move on to the next month. So now the question is, how do I decide how many days to add, what is the number that I should add to the variable days now that I know which month I'm dealing with? I being 1 means it's January, I being 2 means it is February, and so on. So how do I make that happen? You can use an array, but if you don't want to use an array to do this, we have a really tedious way to do it, okay? But in order to code the tedious way, I'm going to use the knuckle trick first, just so that I know, which month is, 31 and which month is not. So we have, okay, here's my hand here, my knuckle. So we have 1, 2, 3, 4, 5, 6, 7. And then we have 8, 9, 10, 11, 12. These are the months with 31 days, and the other ones are the months with fewer than 31 days. Okay? Most of them have 30 days, except for February, which has either 28 or 29 days. Okay? So we'll mark this one as, okay, this is the oddball one. We have to deal with it separately. Okay, so knowing this, how do we code it in the algorithm? Okay. Do you guys want the really tedious way to do this? A very nested conditional statement, yes. Okay, so we'll say if I is 1, or, you guys are not going to like this, or if I is 3, or I is 5, okay, or I is 8, or I is 10, or I is 12. Okay, I'm going to use 1 overall parenthesis to map this. You may not even be able to see the entire thing. There we go. Then what do we do? These are all matching the months with 31 days. So we say days get days plus 31. Okay, cool. What do we do in the else case? Well, I wish we could just do this, but we cannot. Yep. So for anything that is other than February, we can do this. But for February, we also have to check whether the current year is leap or not. So now we have to say, okay, we have something else to check now. There are 2 things to check. So we have to first ask, is I, which is the month that we're dealing with, is it February? If so, we have something to check or something to special logic to deal with here. Otherwise, it's easy. Because if we're dealing with all the other months, then the number of days is just going to increase by 30, because they're all the easy ones. On the other hand, if it is February, then we have 2 cases, because it depends on whether the current year is leap or not. So now we have to look at the year. Okay, we have to invoke is leap again. This time we use d.year to specify parameter y. If it is in fact leap, then days is going to increase by 29. If not, days is going to increase by 28. All this logic just to figure out how many days to add for a particular month. Great. Now, are you guys starting to see, how human standards are actually very difficult from the perspective of computers? No, not really. Okay, so let's double check the logic here, because after I write a chunk of code, I like to double check and make sure the code does make sense. I is initialized to 1, which is January, and as long as the month is prior to the month that I'm currently in, I'm going to add the number of days for that month. Wait, hold on a second here. So that means we never really have to deal with this case here. Because if the date has a December, as the month, I will never have to add the number of days of December. Does that make sense to you? Okay, so let me ask you this question. What if the date that I'm giving you is 1970, December 1st? Okay? What would be the number of days between 1970, January 1st, and 1970, December 1st? Would that be approximately 11 months, or would it be 12 months? 11 months. So that's why we are not adding the month that we are currently in D as a parameter. Is that okay? So all of these little things, okay, whether it's less than or equal to, they are actually very important, okay? Because if you miss by one, then you'll be counting one more year or one more month. All right, so we got the year done, we got the month done. What else do we need to do with days? Well, that's easy, because all we have left is the day of month of the date that we're given with. So it's just DOM. But hold on a second here. This is wrong too. Because what if D inside D is 1970 January 1st? How many days are between 1970 January 1st and 1970 January 1st? Zero, right? If I do this, there'll be 1 day. Because DOM is 1, right? So that means we have to offset it. That means, in order to get this logic right, we have to subtract 1 from DOM. Because our first day of month really should be 0. Because there are 0 days between that particular day and the beginning of the month. Does that make sense? Do you see how our convention of first being 1, second being 2 is really throwing a wrench in, this kind of math? We should be counting day 0, day 1, day 2, month 0, month 1, month 2, instead of starting everything with 1. So you will see this in cisp300 and all subsequent programming classes. In computer science, we tend to count from 0, not 1. Okay. All right, so this gets most of the work done because the most difficult part of converting from the number of days since 1970 January 1st has to do with the year and the month. The rest is actually relatively easy. Now that we have the number of days already computed, let's get to another local variable, which is number of seconds. So we have another local variable here, and we'll say local seconds as an integer. So we'll start off with just the number of seconds of the day, given the hour, minute, and second. How do we compute the number of seconds? That one is actually pretty easy. So I'll let you guys try to think about it. What do we do with the hours?
Multiply by 60.
Multiply the hours by
3600.
3600. Yep. So t dot hour times 3600 would be the number of seconds accounted by the hour of a time. T dot minute, we can multiply that by 60, and then we just have seconds left, which is just added by itself. All right, we're almost done, because now we have days representing the number of days since 1970 January 1st to the day that I'm given with, and we have seconds representing the number of seconds from midnight to the time that is given to me in T. So now we have to combine these two. So how do we combine these two? How many seconds do we have in a day?
3600 times 12.
So it'd be 24 times 60 and then times 60 again, and then the whole thing times days. Is that making any sense? Because seconds first, on line 63, seconds only contain the number of seconds because of the time that we are given as a parameter. But then we have to include all the seconds because of the number of days between 1970 and the date that I'm given with. And each day has, guess what? This is 86400. It's 86,400 seconds. That's the number of seconds in a day. So we have to add this much times the number of days to seconds. So that will eventually be the correct answer. So now we can return seconds. And define sub. Is that okay? Yep.
On line 64,
Mm-hmm.
what is the seconds like inside on the right side of the arrow?
You mean this one?
Yeah, what is that referring to?
That's referring to the local variable seconds, which is the same as this one.
Okay.
So on line 63, we got the number of seconds of that particular day. And then on line 64, we still need that because we have the number of seconds on the day plus the number of seconds of all the days before that particular date since 1970, January 1st. Yep. So I could have combined these two on the one single line. I could have added this portion to over here, but I divided it into two just so that the process is a little bit more clear. Are we doing okay so far? Now, you can also say that the variable seconds is not needed at all because I can just have this expression, okay, this expression combined with this expression as one entire thing and put it right next to return. That will work too, but it becomes kind of difficult to read. Does everybody understand what I just said? Why we can get rid of the local variable that I call seconds? Yes? Okay. But this makes it a little bit more clear and easier to read. This is the kind of trouble that we have to do in order to convert a human readable date and time format into a format that the computer is easily used to. Because everything is now boiled down to a single integer. If you want to find out if a particular time and date is before another time and date, a simple comparison would do because you're comparing two integers. Is that okay? Does it make sense? Maybe. Okay. Are there any questions about this code here? No questions? Okay. What about the other way around? If you're given the number of seconds since 1970, January 1st, midnight, and I want you to convert that huge number of seconds back into a human readable format, which is in terms of year, month, day, hour, minute, second. How would you do that?
We can divide it. Use the divide operation.
Sorry?
We can use the divide operation instead of.
Divide operation. So division is going to be useful. Okay, you can certainly use division. So shall we move on and talk about the other subroutine to convert number of seconds back into a time and date representation that we're used to? Or do we have any more questions about this particular algorithm? No.
Will we trace this one? Will we trace this one?
We could. We could. Yeah, we just have to pick a year that is not too crazy. Because if you give it 2019, that loop is going to go many, many iterations, right? Okay. So we can certainly trace this, okay? You can pick a year that is a year and also a month that's relatively easy to deal with. Okay, so how many people want me to trace that? Okay, very good. So let's go ahead and trace this. And now in order to trace this, I also need to have the setup for the invocation. So we're gonna do that first here. So define submain, and we need a date. Okay, we'll call this D is a local variable. D is a date. Local variable T is a time. And then we have to do some initialization. So, well, okay, we'll have S as seconds, so it's just an integer. And we'll do some initialization. Y dot year is, would 1972 be okay? Do you guys want to pick a year, a leap year or a non-leap year? Either way, it's going to go to is leap and do some work over there. So if you pick 1972, it is in fact a leap year. So is that okay? All right. Let's pick an earlier month. I think March is probably okay. And then we'll pick a particular day. Let's say the day doesn't really matter. Okay, that part does not cause any complexity when we trace. And then T is the time of the day, and it doesn't really matter. What hour do you want? Midnight. Midnight is 0. You know that, right? Midnight is referring to the beginning of a day, not the end of a day. Just midnight without minute or second? Huh?
You can do. And the hour should be 1 a.m.
Nope. Hour should be 0.
0.
Yeah, because in military time, if you refer to midnight in military time, it's 0 hour. Yep. 0 hour.
0.
Is that right? Has anyone served in the military? How do you refer to midnight?
So we count by 100, for example, 900, 1200.
So what about midnight?
So 1200.
0. So I was right. Thank you. I have watched enough movies. Okay, that's all. That's all this is. That's all this means. So we have minute. Okay, we'll have maybe half an hour, and 45 seconds. Okay, so that's the time. So now we need to call the subroutine, and S is going to get the result of invoking Unix time, and we are passing D as a local variable to parameter D, and it's passed by reference, so we need a double-sided arrow, and then we're passing T to T, and define sub, and invoke main. Sorry?
So to initialize the D dot year,
Mm-hmm.
use equal sign, not like a left arrow.
Oh, right. Okay. Thank you. I was teaching assembly language early in the morning, and I was writing a whole bunch of C code. So I got all a little mixed up here. There we go. Thank you. All right. So I think we are ready to trace this particular algorithm. So we'll go ahead and give it a try. I do have a spreadsheet that I can just kind of borrow. Okay. Now this is tedious code, okay, compared to recursion and stuff like that. This one is really just tedious, very tedious. So we do need one column for comments because we have lots of conditions to evaluate. The precondition has nothing to say because we do not have any global variables. So we start with line 81. The return line number is post, and then we have 3 local variables in this case. So we got D, but D itself is a date, which means it has 3 components. Every date has a component called year, another component called month, and the last component called DOM. So D technically is going to take up all 3 columns. And then we have T. T is time. It also takes up 3 columns. because it has got the hour, the minute, and also the second. And then we have one extra 1/3 variable called s. That one is just an integer, so it takes up only one column. And because all of these are local variables, every single column starts with a question mark. In other words, I have no idea of what the initial value is for any one of these integers. So are we doing okay so far with the code at this point?
What is that is?
Hmm?
Because we have second, what that is for?
That's our local variable s,
Okay.
so that we can store the return value of invoking the subroutine. Okay, there we go. So now we can get into the main subroutine, doing a whole bunch of initialization, starting on line 72. So the year is 1972, the month is March, and then the day of month is 28th, and then the hour is 000. Oops. Next row, 0, and we're half hour past midnight, and 40 seconds past, the half hour of midnight. And I'm gonna go back and backfill these 73, and there we go. All right, so now we're on line 78. So on line 78, we have an invocation of the subroutine that we have been talking about. So this is going to take up a lot of columns, because on line 78 we have to set up return info, and return info says we have to go back to line 78 because we got something left to do on line 78 when the subroutine is done. Whatever the subroutine is returning, I'm going to store that into local variable s. So this is what is left for me to do on line 78. And then we have two parameters to pass. D is one parameter, T is another parameter. This is why I said passing by reference is more efficient, because all we have to do now is to say this is a reference to columns D to F. And T, on the other hand, is a reference to columns G to I. So instead of having T and D and T, which are parameters of Unix time, to take up 3 columns each, now each one only takes up 1 column. And that is why it is more efficient to pass a record, especially a bigger one, by reference instead of by value. But then we also have local variables. We got local variable I, and we also have local variable seconds, days, and seconds. Is that okay? Now, because those are local variables, they all start with unknown values, like that. So now, we can continue the execution in the subroutine. So there will be a lot of switching because I can't display both the source code and also the trace at the same time. We're going to start at the beginning of the entire subroutine, which is starting on line 36. On line 36, we are initializing the number of days to 0. So this becomes, oops, right. So this becomes 0. And I can try to save some space by compacting these a little bit. It still won't be compact enough unless we zoom out a little bit. Is that too small, or is that still okay? It's okay? All right. So now we move on to line 37. And line 37 is initializing I to 1970 because we want to count the years. So we go to I. Okay, I have to, it's difficult for me to line up between the line number and the columns now, and the cells. So I is starting at 1970. And then on line 38, we are at the beginning of a loop to count by years. So on line 38, we have to ask the question, is I less than D dot year? Okay, so this is a good question to ask, because for the first time, we have to refer to a member of a structure. So we first have to look up what is D. Now there are a few columns, starting with a D as a header. So when we refer to this D here, which column are we referring to? We are not referring to column D. We are always referring to the rightmost column that has that particular name. So D of row 16 is actually referring to column L. That is our parameter, okay? So when you look up column L as a parameter, D is a reference now to column D to column F. So within column D to column F, I see 3 columns. How should I interpret these 3 columns? That's the question. What do you think? Okay, how do I know that I should look at column D, E, F together as a date? Which part of the program tells me that? Let me switch back to the source code. Which line of the subroutine tells me that whatever D as a parameter is referring to, look at those 3 columns as a date. So which line tells me that? Line 31, exactly. So line 31 says 5ref D : date. So it is telling me that whatever D is referring to, those 3 columns it's referring to, look at those 3 columns as a date. What is in a date? We got a year, a month, and also a day of month. Is that okay? So that's why the type is important, because the type is telling the program how to interpret the columns. All right. So the answer to this question is true, okay? Because I is 1970, and the year that we're dealing with is 1972. So the answer is true. Then we move on to line 39. Line 39, okay, in the source code, is asking us to invoke isLeap as a subroutine, okay? And we are passing I to Y, okay? So how do we do that? So I'm going to do this trick here, just because we have a necessity to do it now. So I'm going to move the columns a little bit so that we can continue to allocate or look at new columns without interfering with the left-hand side of what is being displayed. We can close the door if it's getting a little bit too loud outside. They're setting up something, and that's why they have to move things around a lot. So now we have to use a return info because we are calling isLeap, which returns a value. So when we do come back, we have to get back to line 39. What is left on line 39 to do? Well, we just have to use whatever the return value is in order to decide should we go for the then branch or should we go to the else branch. I'm just going to close the door. And of course, the moment I close the door, they stop doing it. Okay, so we got return info, and now we can allocate a column for the parameter, which is y, and the value we use to specify y is I at this point is 1970. So this is how we set up the function call to isLeap. And then I need to line up the columns. So now we get into the subroutine. The subroutine isLeap, let's see, is all the way up here. So the first thing we do is we get to line 15, which is comparing the mod y mod 4 to 0 and see if they are different. Which line is that again? 15, okay. So on line 15, we are evaluating is y mod 4 not equal to 0? What do you think? We have 1970 as y. So 1970 divided by 4 is non-zero. All we need to know is non-zero. Okay, so that is true. And that means we have to go to line 16. On line 16, we simply return false. Okay, that's good. How do we return false? It's a return statement, which means we have to look up the rightmost in use return info cell, copy and paste it, and then change the question mark to the value that we are returning. and it's false. Okay, very good. So we are going to copy this to over here, change the question mark to false, and that's it. This is what we do with the return statement on its own. Then where do we go? From line 16, where are we going to go next? Line 16 is the then branch of the outermost conditional statement. So when we're done with the outermost conditional statement, we go all the way to the end of the outermost conditional statement, and that means the next line to execute is line 28. We are at the end of the invocation of isLeap. So we get to line 28. Line 28 has got two things to do. First thing is to copy and paste the return info cell so that we know where we are supposed to go back to and what else we have to do on that line when we get back to that line. And then the second thing it has to do is to deallocate the columns that were allocated for this invocation. So we go to Format, Text, and Strike Through. And now we are back to line 39. But when we get back to line 39, we know the condition of the conditional statement is false. So now we have to go to the else part of the conditional statement that starts on line 39. So we look up the code. We look up line 39 first. Here's line 39. This is the then branch. This is the else branch. So we go to the else branch, which is on line 42. And we just add 365 because it is not a leap year to the number of days, which is a local variable. So I'm going to move this part over. So we are updating the number of days here, so which is this number plus 365. Is that okay? It's quite tedious, okay? It takes a lot of work to track the execution of this code. After line 42, what do? We add one to I because line 44 is after the conditional statement. It is also a part of the loop. So we add one to I. So I goes from 1970 to 1971, and that's on line 44. And then we get back to the beginning of that loop, which is on line 38. So when we get back on line 38, I is less than d.year is still true because 1971 is less than 1972. So we just basically do the whole thing again. We go to line 39. Oops, just line 39 without anything else. And then we invoke isLeap again. So when we invoke isLeap, I am just going to be super lazy here. So at this point, it is really just kind of tedious because, for the most part, the interesting logic is already done at this point. So we are really just copy and pasting, changing the 1970 to 1971, which is also not a leap year. Okay, so returning false is still the right thing to do. So that means we still end up, okay, I forgot to copy the line numbers. So that will be 39, a space, 15, 16, 28, and 28 is fine. Then we get back onto line 39. And line 39, once again, has a false condition, which means we end up on line 42 again, which also means that we are going to add 365 to days. Okay. I need to line up everything because I can't see it. It will be whatever it has before plus 365 again. And then we move on to line 44, which is adding one to I. So I is now 1970. Then we get back to the beginning of the loop on line 39. Oh, I forgot to copy this too. Next to 15. There we go. All right. So after line 39, Oh, I copied the wrong thing. It's 38. Okay, so on line 38, I is less than d dot year is finally false. So now we get out of that loop and look at the source code. So after that, we get to line 46. So 46 is initializing I to 1 because this time we're counting months. Okay. Oh, which line is that? 46. Okay, so 46 is reinitializing I as a local variable to 1. And then we go from month to month. So we go to line 47, which is now comparing I to d dot month. It is true to begin with because the month that we're dealing with is what? March. So it will take 2 iterations to go through this. And then the first thing we do on line 48 is a conditional statement. That's when we have that gigantic or. So we look up this and go like, okay, well, I is 1 at this point, right? So if I is 1, then the whole disjunction is going to be true because if at least one of these things is true, the whole disjunction is true. So the whole disjunction is true. And back to the trace, all I have to say in this case is I equals 1 is true. Because I don't have to evaluate any of the other comparison, because if the leftmost one is true, the whole thing is true. Then we move on to line 49, because the condition is true, and we add 31 to days. Okay, so I have to line up everything again. So we look at this one and say it is now whatever you had plus 31. We good so far? Then we get out of the conditional statement. Okay, we skip the second part altogether. And then we get all the way down to line 60, which is adding 1 to I. So I gets I plus 1. Uh-oh, I missed the initialization of 1. Because I should be initialized to 1, and it should be line 46 that initialized it to 1. I think I missed that. So now it is 2, and then we get back to the beginning of the loop, which is on line 47. There we go. So back to line 47, I is now 2, d dot month is still 3, so the condition is still true, and then we get to line 48. So when we get to line 48, if I really want to represent the condition correctly, I actually have to say the entire thing is false. So would it be okay if I just say dot 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 is false? Okay. So if it is false, we have to go to the else branch. So the condition of line 48 is false. We go to the else branch, which means we get to line 51. Line 51 asks, does I equal to 2? Yep, it does. Okay. Then we have a lot of stuff to do, because now we have to call is leap again to see if 1972 is a leap year or not. So are we getting a general sense of how this works? Okay, do you guys want me to actually finish this? This is a great lecture if you have insomnia. There's no need to take any pills, no melatonin. You won't need that. Just repeat this class. Put this recording in the loop, and you'll fall asleep. So but is the logic okay? So now the question is, if I tell you all the rules, okay, if I tell you the knuckle rule about how many days are in a month, if I tell you the leap year rules of divisible by 4 is leap, divisible by 100 is not leap, divisible by 400 is leap again. If I give you all of those rules, okay, there are 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute, can you come up with the algorithm that I just came up with? Now, maybe not instantaneously, okay, but if I give you a week, can you come up with the logic to do it? What do you think? Okay, so you don't have to tell me, okay, but I'm hoping that most of you feel comfortable that given enough time, you will be able to figure out the logic. Okay, it doesn't matter what programming language you're dealing with, okay, because the programming language is really the last step. The logic of getting something done is really the most important part. So what that means is the next class that you're going to take, cisp300, is teaching you how to program in C and C++, which is basically taking the concept that you learned here and translating this code from pseudocode into C and C++ code. How important is that the last part of translation? What do you think? It's not that important, okay? How many programming languages are out there actually being in use by people? I'll give you a rough idea. Okay, so starting with something that you have to deal with, which is C and C++, okay? And the next one that is really close to C, closely related, is Java, okay? What else? What else is out there in industry that people actually use in projects? Python, okay, C#, okay, very good, and Python, okay. What else? PHP, okay. What else? JavaScript, very good. What else is out there? What else is Apple only? Well, for the most part, Apple only. Starts with the S, and then the W. I also want to buy an F and a T. Swift. Okay? And what else is out there? This one is Android only. I cannot even remember the name, but it's an Android only programming language. I should know this, but I keep forgetting it. Okay, and Android programming language. Okay, the first link should, no, it's not Java, but it is something else. Okay, Kotlin, there we go. Okay, so there's Kotlin. The list gets longer and longer, right? How many people used to play Roblox? ROBLOKS, okay, Roblox. ROBLOX, okay, Roblox. And which programming language do you use to program Roblox? Come on, you guys can do this? No? You just play the games, you never try to look into the programming side of it? It's okay, it's called Lua. Okay? So all of these are actual programming languages out there, okay? So now you take one class, okay? And all the subsequent classes are based on C and C++, and then you get your 4-year bachelor's degree after transferring, and you get out to industry, and then your boss can now assume that you know how to program in any one of these other programming languages, plus some more by the time you graduate. So what does that mean? What do you think this is? How do you think this relate to this class? What is the significance of this class? Concept, exactly. So the concepts are the same, exactly. If you want to find a pre-checking loop like our while loop here, they exist in every single one of these programming language. Conditional statement, if then else, okay? And all the different forms of nesting those conditional statements, you can do it with every single one of these programming language. The concept of arrays, the concept of records, okay? They all exist in every single one of these programming languages. Subroutines, okay? Every single one has subroutines. They can all do recursion. They all have parameters. They all have, well, okay, except for C, they all have parameters that can be passed by reference and parameters that can be passed by value, more or less, okay? That one is a little iffy. They all have functions or subroutines that can return a value, okay? The return statement that we have, it exists in different syntax, but in all of these languages. So that means if you need to learn or program in a new programming language, it's what we call just the back end that you have to relearn, okay? But the logic of the code does not change, okay? If I go back to the code that we just looked at, the really, really tedious program that we just looked at, if you learn one of these programming languages and you understand the logic of doing this, it will take you no time to translate the logic into the proper programming language. It is coming up with the pseudocode or the logic of the program that will take you the most amount of time. Is that okay? Does everybody understand that point? Now, even if you go to a 4-year university, okay, the day that you graduate with a 4-year bachelor's degree, is the day when you say, oh, what I have learned is not very useful. Because there'll be new programming languages, okay, that you have to learn on your own for the most part, on the job. There will be new programming methods, new paradigms of programming that you would not learn in a 4-year university. There'll be revision control, okay? How do you debug a program? All of those things you will have to learn, but they're all language independent. It has to do with the application of logic. So are we kind of getting a sense of, why we use pseudocode in this class and why that is not a problem at all when it comes to what I really want you guys to be able to take away from this class? Are we good so far? Now, one thing that I did not talk about a whole lot is how do I come up with this code? How many of you thought that, okay, Tech has everything memorized and that's why he can just come up with this code? Nobody. So you have no faith in my capability of remembering stuff. Fine, that's okay. That's actually appropriate. So how did I come up with this code?
I think it has some rules that you understand that and you go ahead by those rules.
Yep, but how do I teach that? That is the most difficult part of teaching a class like this. Knowledge is easy to teach, okay? The syntax of a programming language is easy to teach. Now that you have the knowledge, how do you apply the knowledge to solve a problem? That is really difficult to teach, okay? But one thing is for sure, okay? I know we are running out of time, but one thing is for sure. If you don't know all the tools in your tool bag and understand how they work, what they can be useful for, you won't be a very good contractor. And that's what I'm trying to do, is to show you what is in your tool bag, okay? And make sure that you know how to use every single tool in your tool bag. Now, how do you use the tools to solve a problem? That's kind of difficult, okay? It's a different thing to teach. So I just want to kind of end the class on that note, okay? Everything is recorded, so in case anyone has a sleeping problem or knows someone who has a sleeping problem, just go ahead and recommend my channel.